Hello, everybody. Let's continue on with normal distributions here. And this time we're going to be talking about areas under that normal distribution bell curve. So just as a recap, I'm going to pull a slide from our last lecture. So we saw normal data. We saw what that looked like. We obviously had this kind of bell curve shape, and we talked about that quite a bit. But here we had data that was the number of states that have high temperatures in these ranges, and we plotted a histogram here. And what we had was we had certain numbers within each range, and we've labeled those there. And so let's say that we're looking at this in kind of a bell curve sense, and let's say that we wanted to figure out some sense of area. And what I mean by area is, let's say if we wanted to take a guess at what percentage of the data was less than 120. And so if I wanted to know how many states or what percentage of states had a high temperature less than 120 degrees, all I'd have to do is I just have to add up the numbers that precede it. So let's say, let's go ahead and mark this in the orange right here. So if we wanted to find the percentage of states that are less than 120, that have a high temperature of less than 120, we would just take these numbers here, 13, 16, 8, and 3, and we would add those together. And when we do that, we're going to end up getting 40, nice and even right there. And so we've got 40 states that have high temperatures less than 120. Well, you could do one of two things next. You could say, well, there are 50 states that we considered, or you could, if maybe you forget there were 50 states exactly, or maybe you forget how many data points you have, you say, hey, look, here's the 7, 2, and 1. 7 plus 2 plus 1 is 10. There's the remaining 10. So 40 out of 50 are to the left of 120. And you'll notice this is equal to exactly 80% right there. So what we could say is all right, the number of data points, the number of states that have a high temperature less than 120 is exactly 80%. Now, we're dealing with a very specific set of data here, but let's say we were dealing with just this idea of a general set of data and just dealing with this bell curve, this normal distribution. So if we have this perfectly normal distribution right here, we have data that basically looks like this normal distribution. So we kind of approximate it by this bell curve. What we can do is we can say, hey, what if I wanted to find the percentage of data that was less than this particular value here, which I'm going to label this value by Z right there. So this is kind of like an x-axis, if you will, and I've kind of ignored a y-axis here because we're just talking about a histogram. We understand that these are heights that we're dealing with. They're frequencies, they're values, they're number of data points. So we've got on this imaginary y-axis that I don't really label, we've got number of data points. And on the x-axis, we have the data points themselves. Well, what we can say is that if I label one of these data points by Z, and you'll notice this has to do with Z-score, and that's why we're labeling it Z. If we look at a particular Z-score, we can say, all right, how much of the data is exactly to the left of the Z-score? And let's go ahead and do a very quick example here. If we were dealing with this Z-score in the orange, which we should know is Z equals 0 because it's right smack in the middle of this bell curve. If we're looking at Z equals 0, then we should recognize that exactly 50% of the data is to the left of this, is smaller than that Z-score. And this makes sense. We're looking right here at the mean, median, and mode if we're looking at a perfectly normal distribution. And so right here, 50% of the data is less than the mean, and then also 50% is greater than the mean. So if we were looking at this particular Z-score, then we would have exactly 50% here. We also saw before, we saw the 68, 95, 99 rule, and that kind of gave us a sense of areas in between certain Z-scores here, whether those Z-scores were 1, 2, or 3 exactly. And we'll get to that later. But what we're seeing here is that with a particular Z-score, that maybe it's Z equals 0, maybe this is Z equals 1, maybe it's Z equals 2, but for some Z-score that we have, we can talk about where we are on this normal distribution. If Z is 0, we're right here dead in the middle. If z is positive, we're definitely to the right of this. If z is negative, we're definitely to the left of this. And if z was something like 3 or 4, if it was pretty large, we'd be way out here on the tail of that distribution. So z-scores give us a way of identifying where we are at in this normal distribution. Now, if we want to find this area that's to the left of this z-score, we're trying to find this purple area here. And remember, this is exactly what we did with that histogram on the very first slide. We took that data for the states and the high temperatures, and we just said, hey, I want to know what percentage is less than this. And we calculated it. We ended up getting that 80% was smaller than that particular data point that we cared about. So now if I'm talking about a particular z-score and I want to find this area to the left of it, well, we actually have a table that will do this. We call it a z table. But basically, there's this table, there's this nice just cheat sheet, if you will, that shows us what these areas are depending on what the z-score that you're looking at, which, remember, the z-score just gives you a sense of where you are within the data. So let's take a look at this z table, and this will look kind of ugly here. So I'll leave this mostly zoomed out for a second. We'll kind of zoom into this a little bit there, and you'll notice here that I have my z-score that goes down and across, and we'll get to that in a second. Let's say that that we're looking at a particular z-score here of negative, let's go ahead and say negative 2.25. Well, what we've got here, if this z-score, negative 2.25 is what we're looking for, then what we're going to do is we're going to go down on the vertical part of the table. We're going to go down these rows until we hit the negative 2.2. And you'll notice right here, all of these rows here, all of these entries right here that I'm boxing, these all just deal with the first 2 decimal places. They all just deal with that negative 2.2. So going down the rows, we're just looking for this guy right there. Then what we do is we actually go across until we hit this particular box that you'll notice corresponds with 0.05. And so it's this sort of intersection between the first 2 decimal places and that third decimal place gives us exactly where we want to be looking at for negative 2.25. And so we've got this number. We'll talk about what that means in a second, but just in terms of getting that practice down for where we're located here. If we're looking at z equals negative 2.25, we just do that. Maybe we're looking at z is equal to negative 0.91. Well, in that case, we would look right here at the negative 0.9. We would look at the 0.01 because that corresponds to that third decimal spot. And then we just find that intersection right there. And so, great, we've got these numbers here, but what do they mean? So let's go ahead and look here. Actually, let's look down here. This will be a little bit better. So if we are located at a z-score of negative 0.91, that means that based on whatever data point we're looking at, we were a little bit better than 1 standard deviation below the mean. Well, what this actually means here, what we're actually saying is that 0.1814 of the data is below that z-score value. You could turn this into a percentage by just moving that decimal place over, and you could say 18.14%. Let's go ahead and draw what we mean here. So if I've got a bell curve, so I've got my bell curve, and let's go ahead. We don't need this axis here. Actually, let's go ahead. We'll put this right in the middle. This will indicate our mean. So we've got our bell curve right there. Maybe not perfectly symmetrical. That looks a little bit better. So we've got our bell curve. And if we're at a z-score of negative 0.91 as we were discussing here, then what we're dealing with is this location. We're looking about right there. To me, that looks roughly like z equals negative 0.91. Now remember, z equals 0 is dead smack in the middle. Z equals 3 is going to be way out here or something like that. So this z equals negative 0.91 looks roughly like it'd be located there on this normal distribution, on this bell curve. And so if I go up and I just say, all right, pretend this is a histogram, how much data is less than that amount right there? What I'm going to do is I'm just going to go right in here. I'm just going to cover up all of that. And what we're saying here is that this is 0.1814 of all the data, which is just a fancy way of saying it's 18.14% of the area underneath this bell curve. Go ahead and circle that, make that important. So this green area is 18.14%. You'll notice all we did was we just took the z-score, which tells us our location, that tells us where we're at on this axis here. And then we just went to our table here, and we just zoomed in and we just said, hey, look, that's that number, that 0.1814. That just exactly tells us 18.14% of the data is to the left of that particular data point. You'll notice that obviously I went to the left here. So we've got that there. We can practice this. We can do a bunch of these examples and get really good at this. It's basically just looking at the table and finding the corresponding area. So looking at this table, we've got in the middle here, all of these are areas. All of these things on the inside here, these are all correspond to area. And then on the outer column and row, that's going to be the z-scores that we're talking about. So the question here is, well, here's all the negative z-scores. What about the positive z-scores? Well, we have that table as well, a two-sided table, if you will. These are all the positive z-scores. So if we were looking at z equals, let's go ahead and say z equals 2.38, we would go ahead and go down to z equals 2.3. Right there, kind of zoom in right there, see that 2.3. And then just to zoom out so we can make sure we see it, we look at this 0.08. So you're recognizing there that I've got the 2.3 labeled right there, and I've got the 0.08 labeled right there. So now it's just a matter, hey, go across, go down, find that value, 99.13%. Now that kind of overlaps there, but 99.13% of the area is to the left of that z-score of 2.38. So we've got the positive side of the z-table, we've got the negative side of the z-table. Just some things to note here, just some notes on this table. Z-scores are rounded to 2 decimal places. That's a big distinction between the areas that are rounded to 4 decimal places. Now, not every z-table that you see will look exactly like that. Some people make their z-tables and they round to 3 decimals for the z-scores and 3 decimals for the areas. But here we're going to mostly deal with z-scores that are rounded to 2 decimals and areas rounded to 4. That should give you a good distinction between which is which. If you see something that's rounded to 2 decimal places as opposed to 4, it's likely a z-score, and vice versa. Now, if we look at the negative side of our z-table, there's a row for negative 0.00. And that looks weird. That almost looks like negative 0, which obviously we know that there's no such thing as negative 0. So, but let's go ahead and look at this. So if we're looking at this negative side of the z-table, you'll notice here all of these negative values. We've got all of those right there. Down way at the bottom here, we've got negative 0.00. And the reason for that is because we want to make sure that we're actually talking or able to talk about z-scores such as negative 0.04, let's say. This is still a negative value, so we have to look at the negative side of the z-table. If we cut off this bottom row right here, and we just stopped at negative 0.10, we'd have no way of getting to this because this z-score, to zoom out and kind of show this all together here, we would have to look at the negative 0.00 again to look at those first two or those first two decimal places, if you will, or at least to the one place to the left of the decimal, one place to the right of the decimal. And then we have to look at the 0.04 to look at that last 0.04 part. So we go all the way down, we come all the way across, and we get this 48.4% right there. And so this means that 48.4% of the data is to the left of z equals negative 0.04. So this looks a little weird having that negative 0.0 row, but it is necessary for those z-scores that fall in that range of 0 to negative 0.09, as you could note right up there. So we've got that. That's a little bit of a caveat here. Some other things is that on the negative side of the z-table, the area that we're looking at increases from top right to bottom left. Let's go ahead and look at that. Let's look at the negative side here. So what you'll notice is that if I start in the top right, I'm going to zoom way over here. So if I start over in the top right up here, if I were to look at a z-score of negative 3.49, my area is going to be right there. That's going to be this corresponding 0.09 and negative 3.4 right there. So you'll notice that this area is very, very small. It's 0.02%, 0.0002 out of 1. It's very, very small. It's almost 0, basically. And you'll notice that as I start to move across here, these actually get larger. They don't get larger very quickly. You can see actually all of these are 0.0003. But as I move across and then as I move down, these get larger. As I move here, you'll notice that, hey, look, 0.04, 0.0005, 0.0008, 0.0011. And as I start to come down and across, these start to get bigger and bigger as I move from top right down to the bottom left. And what's happening here is my z-score is changing such that as I increase this z-score, so as I start at z equals negative 3.49, as I move all the way over to at least what I've got zoomed in here, what if we looked at negative 1.70, I'm moving this z-score to the right here. And so what's happening is more area is being considered. Here, I'm only considering this area in the highlighted red. But now at z equals negative 1.70, now I'm looking to all of this highlighted area. So as my z-score moves from left to right, my area is increasing. And watch that happen here. If I were to, well, let's look right here instead. If I were to change my z-score to here, this is the area that I'm considering. But now, if I change my z from z1 to z2, if I push that z-score to the right, if I increase it, then my area gets larger. Instead of just looking at this right here in the highlighted red, I'm looking at all of this in the purple. And so as our z's increase, we expect the corresponding area to increase. And what you should notice here on this table, at least, is that as we move from negative 3.49 all the way down to z equals 0.000, as we move down here, those areas do in fact get larger because our z-scores are getting larger. And here's one last thing to note. Right down here at the bottom, at exactly z equals 0, we have an area of 0.5, otherwise known as 50%, which remember, 50%, that's right dead smack in the middle of that bell curve, which makes sense if z is equal to 0. Continuing on to this other side here, the positive side of the z table, you'll notice that when z is equal to 0.00, we're starting right at 0.5 because z is equal to 0. And we've seen that before already. We've seen that if our z is equal to 0, we're right on the mean, median, and mode. And so our area to the left of that is just 0.5. Just as a recall here, try not to forget that first example that we did here on the with the histogram. We we started off here and we said, hey, let's just go ahead and look at the data that's to the left of this particular point. And we just manually calculated it. We just said, hey, there's 40 data points divided by 50. That is in essence what we're doing here. We're just saying, all right, if z is negative 0.91, that corresponds to a particular data point. And so let's just count all of the data that's to the left of it and count that and divide it by all of the data, 100% of the data, all of it. And so we just get these values here. So don't let these tables scare you. They're just a lot of areas. They're just a lot of areas that you could calculate. Just to wrap this all up, if we were to go up to 0 equals 3.49, you'll notice that the areas get larger as I move from top left to bottom right. Actually, I lied. One more last note. You'll notice that 3.49 is the largest value we have here. You obviously could have z-scores that are larger than that, but we just don't bother with them because as you can see, 99.98% of the data, that's a lot of it. We just don't really bother to go any more. You could have z tables that go into higher z scores. We just don't really care. Z equals 3.5 is probably higher than you'll ever see in your life anyways. So there we go. We've got some notes on the z table, some important things to remember. So let's go ahead and do a couple examples here. Find the area to the left of z equals negative 1.37. Well, we'll go ahead and we'll go to our z table. We'll say, well, if we're going to look at the negative side of the z table, we're doing z equals negative 1.37. Then we're going to go to the negative 1.3 row, and then we're going to go to the 0.07 column. So you'll notice that I'm looking right there, and I'm looking right there. And then we just find that corresponding area. 0.0853. So what we might say, 0.0853. This is equal to 8.53%. So if you were taking a test in a class and you saw the mean and the standard deviation for the test scores, you could calculate your z-score with that information. And if you found that your z-score was negative 1.37, that would mean that you were 1.37 standard deviations below the mean, which would mean that your data point, your exam score, is higher than 8.53% of the other exam scores. This exactly corresponds to the percentage of the class that you actually did better than, because if their score is less than you, that would indicate that they're to the left of your z-score. They have a smaller z-score, a more negative z-score. But here we go. We've got our answer, 8.53%, confirmed right there. And so that's the area to the left of that z-score. So if you were to say, hey, I took an exam and my z-score was negative 1.37, someone else could go to their z-table and they could say, oh, so you scored better than 8.53% of people who took that exam. And you'd say, yep, I beat 8.5% of the class. Great. So there we go. Got a good example there. We've done this a handful of times where we found area to the left of z-scores. Let's now talk about finding the area to the right of the z-score. And before we get into this, I want to go back to something I just said here. We said, oh, if you were the person that was z equals negative 1.37, that means that you beat, let's just round and say 8.5% of the class. So if you beat 8.5% of the class, you'll hopefully notice that that would indicate that 91.5% of the class beat you. If you beat 8.5%, there's still 91.5% of the class left over. So they beat you. So if you wanted to find the percentage of people that were better than your score, better than this z-score, and when I say better than, I mean to the right of that z-score, you're just going to do exactly this calculation here. You're just going to kind of flip it, take the opposite of that percentage. And so let's go ahead and look at this. So area to the right of a z-score. If I have a z-score here, which this is clearly a positive z-score because z equals 0 is right in the middle here. That's z equals 0. So we're dealing with a positive z-score based on how this graph is drawn. We know how to calculate the area in the blue. We've done that. We've done a handful of examples. We just did one right here. It was area to the left of z equals negative 1.37. So we know how to find the area to the left. That's easy. We look at our z table, boom, we've got it right there. But now if I'm asking for the area to the right, what I want to notice here is that this entire area here is 1. It's 100%. It's all of the area underneath this curve, which is equal to 1. So if I want just this area in the pink here, then just this pink reddish highlighted area, I'm going to take the 1 area and I am going to subtract off the blue area. If I take, let's go ahead and actually mark this in kind of a green. If I take the area encapsulated in the green and I subtract off the purple, that's just going to give me the red. So if I give you a z-score and I say, hey, I want the area to the right of that z-score, you're going to just do 1 minus the area of the left of the z-score. And this up here, this area to the left, we know how to find that just with our z-table. So let's do an example. Find the area to the right of z equals negative 1.37. Oh, well, luckily, we've already found the area to the left. So all we have to do is find that area, which we already did. We got that 0.0853. We do 1 minus that area to the left, and that gives me that 91.5 rounded, that 91.5% that we saw. So what's happening here is we've got a normal distribution. Ooh, let's make that a little bit more like a bell. So we've got a normal distribution there. Took me a couple tries to draw that. And we have a z-score that looks, I don't know, let's just say it's right there. Z equals negative 1.37. What we did here is in the green, we found this area right there. And that's all of this in the green. It's all of that area right there. And that area was 0.0853. And now because we know that the area underneath the entire red curve, the entire bell curve, the entire normal distribution, because we know that area is 1, to find the area here that I'm going to draw in the purple, that area is just 1 minus the area in the green. And so we just do that calculation, 1 minus area in the green, and that exactly gives us the area in the purple as this 91.47% right there. Boom. So there we go. Find the area to the right of z equals negative 1.37. We just do 1 minus whatever the z table tells us. And luckily here in this example, we already knew what our z table told us because we did it on the last example. So we've got that there. That's area to the right of the z-score. The last thing that we're going to see here is finding the area in between 2 different z-scores. So let's say that I gave you 2 z-scores, z1 and z2. If I want to find the area between them, meaning this area right in here, I have to get a little clever. The first thing that I want to recognize is that in this purple region, all of this, that's the area to the left of z2. That should be pretty clear. We could just cover up z1. We just don't care about that. All of this in the purple is the area to the left of z2. So our z table will tell us exactly what that is. We can go ahead and see our z-score for z2, and we can just look at the area to the left of it based on the table. Now, also what we have is the area here in the red is just the area to the left of Z1, which again, we can find from our Z table. When we hear that word left, area to the left, we think Z table. Now you'll notice this purple area, this is the desired area. This is what we're being asked to find. If we're asked to find the area between Z1 and Z2, that's just this purple right here. And so what I can do is I can take the area to the left of Z2. So let's go ahead and outline that in green here. So I've got that area right there, and that's given by the Z table and Z2. And then I can just take the pink area, that pinkish orange area, and I can just subtract that off. And then we just get the purple. So what we're going to do is we're just going to take the Z-score value, the Z-table value for Z2 and subtract off the table value for Z1. You'll notice here that I'm always doing the larger Z-score minus the smaller Z-score, or at least the areas that they correspond to. So let's do an example here. I've got Z equals negative 1.43 and Z equals 2.56. Well, obviously Z equals 2.56 is larger than negative 1.43. So this is going to be our Z2 in this example back here. And then this negative 1.43 will be Z1. So let's go ahead and do this. Let's go to our Z table. Let's go ahead and look at the positive side first. So we've got Z is equal to, there we go, Z is equal to 2.56. And so we're going to go to 2.5, 2.5. And remember, that corresponds to these first two spots right there, the first two numbers. And then we're going to go to the 0.06. And remember, that corresponds to that right there. And now we're just going to go down. And actually, what I like to do sometimes here is I just like to make a big line straight down, big line straight across. And then I just look at where that intersection is. And then I kind of just erase accordingly, just right up until I see it. Boom, right there. 9948, 0.9948, 99.48%. So we got that there. That's good. We'll keep that in mind. We'll keep that here. Now let's go ahead and look at that other Z-score. Z was equal to negative 1.43. And so what we're seeing here is negative 1.4 and then 0.03 yet again, first two, and then the last one. So we go down, we go across, and we get 0.0764, 7.64%. So now what I'm going to do is I'm going to take note of each of those areas. So let's go ahead and do that. So we've got, area to left equals 0.0764. And then right here, we've got the area to the left equaling 0.9948. There we go. So we've got that right there. And now remember, all we're doing is we're just taking this area all right here, which we found, it's the 0.9948, and we're subtracting off this area, which is the 0.0764. So we take these and we just subtract them. If we go ahead and do that, and we're going to get 0.9184, 91.84%. We'll wrap that all up right here on this slide just to take a look and recognize that we went to our negative 1.43. We identified that area right there, that 0.0764. We went to the 2.56 on the Z table. We looked at the 0.9948. We just subtracted those values, and that gave us the area in between, which we can then write as a percentage, 91.84%. Just as a visual here, this is what this looks like. We have Z equals 2.56 and Z equals negative 1.43 labeled right there. You'll notice again that, or just I'll point out here that this is Z equals 0. Let's go ahead and make this a straight line through. This is Z equals 0. This is z equals 2.56 and z equals negative 1.43. And so we found this reddish orangish area in this problem. That reddish orangish area is 91.84% of the entire area under this whole curve. So there we go. We've got three different ways, three different types of problems you could see here from this lecture. You could be asked to find the area between two z-scores like we just did. You could be asked to find the area to the right of a z-score, or you could do the much simpler, find the area to the left of the z-score. And within all of these, you always have to find the area to the left of a z-score, which means that you have to use that z-table that we've talked about. And we've made some notes on that z-table, and that's actually just going to be it. We've got these three types of problems, and you can go ahead and move on in doing those. So we'll go ahead and call that the lecture, and have a good day.